What we're looking at today is measuring angles and looking at angles. Now, what we normally measure an angle with is a protractor. So this right here is a protractor, and it measures in degrees. Now, there's two different ways that we can go about using it. And if you notice that there's an inside set and an outside set. So if I'm measuring from the right, if I'm measuring from over here, I start at 0 and then come all the way around to 180. If I'm starting from the left side, I start on the outside and go around this direction. So there's two ways that we could use it, going from the left or going from the right. And it gives us that option. Now, these here, you've already had them. An angle is a set of points consisting of two different rays. A set of points consisting of two different rays. A vertex is the end point of the two rays. Bless you. Bless you. And the sides are the two rays. Now, whenever we name an angle, there's one of three ways that we can do it. The first is by the vertex. And we'll put a little angle marker telling us that it is an angle in the vertex. Now, the only issue with this here is that there can only be one angle. If it's possible to have two different angles at that point, we cannot name it by the vertex. Now, when we look at this here, there is just this one angle. There's only one angle here. And that'll make more sense when we look at some of the other ones going forward, and I'll point that out. But here, since there is only an angle, we can name it by the vertex. We can also name it by 1. They will sometimes put a number inside the angle, right between the two rays, and we can use it to name the angle. So here it's angle 1. And the last way is by using the 3 points. So there's 2 points, C and B, that are on the rays, and then there's the vertex. Now we can name it CAB or angle BAC. We can name it as either one of these here. But the key feature to this is that the vertex, angle A, or point A, that point of the vertex, has to be in the middle. It has to be in the middle. So kind of like what we did with polygons last week, where we started at a point and went around, it's very similar to this here, because we'll start at a point C, follow it down to point A, and over to point B, or B to A to C. It's almost like we're tracing the angle itself. So we can't say CBA or BCA. Those don't work. They'd be talking about a different angle. So whenever we're using 3 letters to name the angle, the vertex has to be between the other two. As long as we keep the vertex between the other 2 points, we will be able to name the angle. Any questions on this here? Interior of an angle and exterior of an angle. Interior, all the points inside. Exterior, all the points outside. And since they are 2 rays, we consider them to extend indefinitely if we just have an angle by itself. Any questions on this so far? Okay, let's look at our first example. And our first example is mainly going to be dealing with naming angles. So we look at this here. A lighthouse keeper measures the angle formed by a lighthouse at point M. And there are 3 boats. Name 3 angles shown in the diagram. This here, let me use this and, nope, wrong button. There we go. Let's start off with red. So I can say that this here is a ray, yes? And I'm going to pick a different color. Let's say light green. This here is a ray, and then let's say dark blue. So all 3 of these here are rays, yes? Well, the red and green make an angle, yes? The red and blue make an angle, yes? And the green and blue make an angle. So if I said vertex A, or not vertex A, vertex M, which color pair am I talking about? And, well, there's 3 different angles there, yes? So do I know which one I'm talking about? Well, no. This here is a type of example where we can't use the vertex. Because since there's 3 different angles that we could be talking about, we cannot use the 1 letter to define it. We have to use either the 3 letters or if there's a number in the middle. Because if they use a number in the middle, they'll name it as 1 and 2 to show the difference. So, since we can't use the vertex, can someone give me a name for the angle? So JML, JMK, LMK. Let's keep going. KML. Yes, M is going to be our vertex. So we need all 3 and the little angle marker. So let's see what we name. JMK and JML. KMJ. 2, 3, 4, 5. We need 1 more. So KMJ, KML, MLK. We can't use MLK because M has to be in the middle. LMK, LMJ. Because each one of these would have 2. So with point J at the start, we could have 2. L, we could have 2. And K, we can have 2. Any questions on these here? Okay. So let's look at number 1. Let's do at least 2 more. What's another way we can name angles for number 1? P, Q, R. And there's 1 more. An angle Q. Because since there's only 1 angle there, we can name it by the vertex. How about number 2? So Y, Z, Y, X, and so we do have Y, yes. X, Y, Z, since they gave us the number. So yeah, we did have Y. Oh, okay. For some reason, I kept hearing Y. Let's just go on and do the last one. We will have FED, yes. DEF, Mm-hmm. And that's it. All right. The protractor postulate. There's going to be a lot here, so let's actually talk through it and then we can put something down. Consider OB, ray OB and point A on one side of line OB. The ray OA can be matched one-to-one with the real numbers from 0 to 180. The measure of angle AOB, which can be written as measure AOB, is equal to the absolute value of the difference between the real numbers matched with OA and OB on a protractor. You can use a protractor to measure. So we said if this is a line, and we have a point A that's above that side of the line, I can use this protractor to subtract the difference from the location of where this line passes and this line passes to find out its measure. Or we can count around. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140 degrees. Now, by what they're saying is, well, we can say this is at 180, and this over here is at 40. Well, I can say 180 minus 40 is, so it's just taking where they're at and subtracting the two. Or we can count. So I don't put a big emphasis on that definition because it's really where they at, subtracting, or we can count. Now, we do have 4 different types of angles we'll look at. One is acute angle. An acute angle measure is greater than 0 degrees and less than 90. So an angle between 0 and 90 is acute. A right angle measures exactly 90 degrees. An angle between 90 and 180 is obtuse. And an angle that is exactly 180 degrees is a straight line. Now, if we go past 180, we actually measure the smaller of the two angles. Because if you notice here, on an obtuse angle, the bottom side of it is greater than 180, yes? But we don't talk about that one, we talk about the one that is less than 180. So even if we have a line that's going this way, we're not going to talk about it in this direction. We're actually just going to talk about it in going the other direction. We always look at it between 0 and 180. Now there are angles that are greater than 180, but when we're talking about the actual angle, we're looking at the one that is less than 180. At least here, if we're talking about acute, right, and obtuse. So we want to find the measure of each angle and then classify it as acute, right, obtuse, or a straight line. So looking at letter A, G, H, K. So we have G, H, and K. It would be obtuse. Now we need to find this actual angle measure. Well, where's GH starting at? At 0, yes? I'd use the outside lane because, well, that is where 0 is at, yes? We wouldn't use the 180, but if I was to count it, I'd start at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and 125, yes. So 125, degrees, we put a little degree marker to signify that it is degrees. Now, we won't cover it too much in here, but there is such thing as radians. We can also measure angles in terms of radians. Okay. That was our first one. Let's look, if there are no questions on that, let's look at the next one. Let's look at JHL. JHL. So yes, well, let's count it first. Would we use the inside track or the outside track? Inside, because that's where zero's at, yes? So 10, 20, 30, 40, 50, 60, 70, 80, 90. So this would be a right angle because it is 90 degrees, yes. If the angle's measure is 90 degrees, then it's right. If it's 89.9, it is not a right angle. It has to be exactly 90 degrees. Any questions on the first two here? Let's look at the last one, LHK. LHK, I would agree it is acute. Do either of them start at 0? No. So there's two things we can do. Well, I know this one here is at, and this one here. So I could say that this is 125 minus 90. And we would say the absolute value is equal to 35. Or we can do 90 minus 125, and it's going to be 35. Because again, the measure of an angle, the measure of distance are always going to be, or the measure of an angle can be negative, but we want to look at the positive. There are cases where we'll talk about a negative angle. Now, that's not the only way that we can do this. So it starts at 90 here, yes? Well, from 90 to 100 is 10. From 100 to 110 is 20, 30, and then 5. Because each one of those little hash marks, the small ones, are 1 degree measure. So I could actually count the markers from 90 to 125 and get 35. So we don't just have to use the 125 minus 90 or use the 90 minus 55. We don't have to use those, but we can also count. We can use one or the other, and it'd give us the same answer. Any questions on this here? Okay. Let's look at JHM. JHM. Obtuse. Now I see that JH is at the 0. Yes? So that means I can really look over here. So it's between 30 and 40. So this is 35 degrees. Yes? Why wouldn't it be 35? Right? But it is between 30 and 40, isn't it? On the marker. Which one did I start out with? We started out at 0, yes? Was that the inside or the outside? It's inside. 0 starts on the inside track. So if I'm looking just at the numbers on the protractor, well, we started out at 0. Okay. Even though it is between 30 and 40, it's actually 145 degrees. The angle going the other way would be 35. I did that on purpose because, again, on the homework assignments over the past so many years, I've seen so many people do that exact same thing. Where we see, okay, that's where the angle's at. It's between 30 and 40, so it's 35. Well, no, we were coming from the other direction. The smaller angle that does compose it is 35. And there is a special property with these two, but we'll get into that tomorrow. Let's look at the next one, MHK. MHK. I would be hesitant at this point to say right. I'd be hesitant to say obtuse at this point because it does look like a right angle, yes? But a right angle has to be exactly 90 degrees. And the difference between 89 and 90 is so small, it's hard for us to actually see it. So we need to find the measure first. So we look at this here. So they're both on a 5, yes? So we can say 5, 10, 20, 30, 40, 50, 60, 70, 80, and then so 85, 90 degrees. So it is a right angle. So it is a right angle. So for that there, we just need to make sure and figure out what the angle was first, just on the off chance that they had it bumped to a 4 on that last count instead of a 5. Now, if you look at this here, for that green line I drew, that would be 89. That'd be 89 degrees, where I drew the one on the board. No, it would be 89 degrees. So, as you can see here, unless you're standing right up on top of that with the protractor, it's hard to tell the difference between 89 and 90. They're so close. So unless we know that the angle is 90 degrees, we cannot assume it is 90. Now, less than 90, yeah, we can assume it's acute. Greater than 90, it's easy to tell. But 90 is the one we need to make sure. MHL. MHL. Well, that is definitely acute. Less than 90. Now we just need to find out what his measure is. So this is in the middle, so we have a unit of 5, 10, 20, 30, 40, 50, so its angle measure is 55 degrees. Now if we wanted to use the kind of formula for it, well, we can say 90 minus 35. Well, 90 minus 35 is either way works. Either way works for this here. Questions on any of this here so far? Identify congruent angles labeled in the quilt design. Now this is a little hard to see because the printer, even the printers that we had before these that we currently have, had a hard time printing this out. So this here is a little bit hard to see. So I'm going to go and turn the lights off so that we can see it a little bit better. It's not as washed out, and I'll turn them back on. Now, if you noticed on both of these here, we do have these here and these here. These little curves, these arcs. And what these are used for is to label congruency. Because any other angle that has the same number of arcs are congruent to each other. If you notice when we talked about midpoint and angle or segment bisector, where we had little dashes drawn on the line, those were there to show that those two sections were congruent to each other. So we have these markers to show congruency. So looking at this here, well, if we want to label congruent parts, well, we could say angle F is congruent to angle, not G. Angle F has how many of those arcs? 2, yes? Which other angle has 2? D. Because the one up top and the one down below both have an angle that are congruent to each other because of those marks. Now we could say angle EFG is congruent to angle ABC, or use the three letters. We could do it in either way. The reason we can use the vertex is because on each one of those figures, there's only one angle at each point. There's only one angle at each point. What's another set of congruent angles here? G is congruent to angle B. Because if we look up here, G has 1. And down here at the bottom, B has 1. So we could use angle HGF and angle CBA. We could use three letters, or we can use just the one. Okay. Any questions on part A? Now, if we say two angles are congruent, it means that they have the same measure, just like with line segments. If two line segments are congruent, it means that their lengths are the same. So for two angles to be congruent, it means that their angle measure is the same. Now, if we're told that the measure of ADC is 140 degrees, well, ADC, because those two angles are congruent to each other. I'm going to turn the light back on. Any questions on this here? You good with this here? I have a feeling you're not going to have to write anything down for this. Point, if P is in the interior of RST, then the measure of RST equals the sum of the measures of RSP and PST. Okay, so if we have an angle, and point P is in the middle of the angle, well, it makes this angle and this angle here, yes? And if I take those two angles, measures, and add them together, I get the whole. That's all this is saying. If P is in the interior, then RST is equal to RSP plus PST. So if there's a point that cuts the angle into three, or into two different angles, their measures added together give us the whole. So unlike with line segments where we're just given a measure and then kind of, okay, well then I can add it and subtract it, we're going to actually look at some of these here. They're going to give us equations right out the gate. Now, they told us KLN, or LKN, this entire angle is 145 degrees. The whole angle itself is 145 degrees. They told us that right out the gate. Well, from the formula we just had, it said that the measure of LKN is equal to the measure of LKM plus the measure of angle MKN. Because again, the whole angle is equal to the sum of the two that make it up. Yes? Questions on this here so far? So what we're saying is whatever this angular measure is, plus this here will give us 145. These two added together will give us 145 degrees. So they told us the measure of LKN is 145 degrees. Well, they didn't actually give us a specific measure for the other two angles, but they told us LKM value is what? 2x plus 10, because that's what the angle is. It's been defined as 2x plus 10 degrees. That's what its degree measure is. Now the other one was defined as what? So we're able to set this up. And the reason we're doing this is because if I can find the value of x, then I can plug it back in to find the measure of each angle. Well, we do have some like terms that we can combine 2x and, which should give us. And then we have 10 and negative 3. So 10 minus 3 would be 7. So it gives us 6x plus 7 on the right-hand side. Are all the variables on one side? Well, I just have 6x on one side, and I have 145 on the other. 6x is already by itself, isn't it? So we don't have to worry about trying to get the variables on the same side, but we do need to get them by itself. So I wouldn't divide first. I would subtract 7. I try to take care of all of the addition and subtraction movements, adding or subtracting things to both sides first, because that's easier to work with, and then do addition or multiplication and division last. So 7 minus 7 would give us 0, leaving us with just 6x. 145 minus 7 is going to give us 138. Y'all can type that into the calculator to get that. Now, we don't have anything else added or subtracted to 6x. So now we can divide both sides by 6. X is going to equal Any questions on how we got the value of x? Is that what it wanted? What did it want? It wanted the measure of each angle. Well, the measure of angle L, yes, was told to us to be 2x plus 10. Well, I already know the value of x now. It's 23. Now, at this point here, if you wanted to type that all in, 2 times 23 plus 10, and hit enter, the calculator would do it. 2 times 23 is going to be 46, and 46 plus 10 is 56. So that there is one part. Now, the measure of angle M we also have to find. Well, we can do the exact same thing we just did and plug it in and say 4x minus 3. Well, we found out x is 23. And 4 times 23 is 92. It also works out if I do 145 minus 56, I'll get 89 as well. Because our 56 and 89 should add together to be what? The whole thing, which is 145. So these two angles should add together to be 145, and they do. So that's another way we can check to make sure we got the right answers. Any questions on this here? Let's look at the next one. Given KML is a straight angle, so what's its measure going to be? 180. It's a straight line. Find KLN and NLM. Well, I know that these two here are going to add up to be 180. So 180 is equal to 10x minus 5 plus 4x plus 3. Well, we can combine like terms. 10x and 4x makes negative 5 plus 3. It would be negative 2. Add 2 to both sides to get x by itself. 14x is equal to 182. Both sides by 14. And x is equal to 13. Then we can plug it back in. So I'm going to do the measure of angle KLN, which is our 10x minus 5. So we'll do 10 times 13 minus 5. Well, 10 times 13 is 130. Minus 5 is 125. Measure of KLN is 125. Well, the measure of angle NLM. Well, what's the whole thing? What was the other angle? Because those two angles added together to give me 180, yes? So if I subtract the one I know from the total, it should give me the other one, which is 55. Because we could have done it by hand and done 4 times 13 plus 3. Well, 4 times 13 to carry the 1 is 52 plus 3 is 55 degrees, which is exactly what we got. Any questions on this here? I think we still have a few left in the note sheets, yes. But